So the idea behind this project is to create an interface, a sound interface between the outside of a swimming pool and the inside of a swimming pool. This way, with this interface, every swimmers inside the swimming pool with their heads in the water will be able to hear everything that happens outside of the swimming pool. The device I'm presenting in this video is really a prototype of a platform that can allow you to make a better version. It's really just the first step. These are all the parts I just received from JustAway. They are a sponsor of this video and this project couldn't have happened without them. So everything is super well packaged. I have 4 parts in this order for this project. It is both 3D printed part and CNC part and laser cutted parts. So this is the nylon cover. The quality as usual is perfect. Very, very smooth. So now let's move on to aluminum CNC part. This is a ring of aluminum, very well packaged as usual. The finish is just perfect. 20 holes that are all tapped, and that screw in perfectly as expected. So now I have one 3D printed part and one aluminum ring, and everything lines up perfectly. So this part is laser cutted. This is the first time I've ordered laser cutted part from JustAway, and the result is just perfect. Everything is well deburred. The finish on the part is perfect. Very, very smooth, and everything aligns perfect. Now let's move on to the final part that is also CNC'd. So this is the top part, and just like the other parts, the finish is just beautiful. Absolutely perfect. So the geometry here is a bit more complicated, and still the result is perfect. Very, very smooth. Every holes are deburred, and everything lines up as expected. So this is a dry mount. So the speaker is mounted pointing up. Here you will have a silicone joint, but here is just a dry assembly just to see if everything's aligned. So then this vibrating plate that will be pressed on the speaker that is right below. Everything lines up perfectly. You'll have another seal here, and then the bottom clamp that also obviously lines up. And so this is upside down, and in the water it will be on the other side. And then you have 20 holes all around the nylon cover to screw everything on. So I've also made a custom PCB, and I've used GLC PCB. GLC PCB is not a sponsor of this video, but it is the service I usually use to make my custom PCBs. So this is a DC-DC converter. The result is perfect. Very well packaged also. The way it works is that we are going to use a Bosch 18-volt battery. And so this white part is just a 3D print to make sure that I have all the dimensions right. But basically you will have a case that holds the Raspberry Pi and the custom PCB. And allows the custom PCB to make contact with the battery. The PCB itself locks in place onto the battery, and all the leads point downwards, and you can see that it aligns with the slots on the battery that are actually the leads of the battery. So here's the PCB with the header mounted. So this is the Raspberry Pi I will be using, and you can put the custom PCB upside down and connect it. And that's it, basically. And in the final case, everything will be mounted. So the Raspberry Pi, the custom PCB, and everything will slide onto the battery. The battery is 18 volts. I need 5 volts for the Raspberry Pi, but I also need 18 volts. So these leads are used for the This is just a quick look at the speaker. It's not really a speaker, it's called an exciter. And so you have the black part that is stationary, and then you have the metallic round part on top that will make contact with the vibrating plate and create the sound waves in the water. So the speaker is mounted onto this aluminum part. You can see the holes lined up perfectly. Then you'll have a silicone seal to make it watertight, and for the vibrating plate to be able to float and to deform a bit without being just screwed on the large aluminum CNC part. So this is the PCB housing that will house the custom PCB and the Raspberry Pi. So you can see here these are the leads that are soldered on the custom PCB, and upside down, and make contact with the battery connectors. Because they align with the slots of the battery. This is a quick overlook of the mold for the silicone seal, all 3D printed on a classical FDM printer, very thin. So I've glued it onto this wood board. It uses only 2-part silicone that you can buy from Amazon, for example. Just mix it, pour it carefully. Make sure to fill it completely. My silicone to 24 hours to cure, and then I can just remove it from the mold. The mold already has the space for the screw holes, so it's already pre-pierced. And you end up with the silicone seal or gasket with some flashing that you can remove by hand. So now I'm just checking the alignments, checking if everything's okay with the aluminum part from Just Way, and everything lines up perfectly. So it is a bit thin, but you can kind of see it here, and the holes line up perfectly. So these are all the mechanical parts. We'll see the electronics in a little while, except for the speaker that we're going to have to mount right now when we are building the enclosure. The rest of the electronics will be seen afterwards. So we're going to build the enclosure from the bottom up. So we start with this. This is the ring that has all the threads that we are going to screw the top cover into. So we need first this, then we need one silicone gasket. Let's try to align all the holes. Perfect. Great. Then we have the thin aluminum plate. This is the vibrating part. This is what the speaker is actually pressed onto, and this is what actually produces the sound waves underwater. So let's see, I'm going to try to align this. You can see that the holes on this plate are quite a bit bigger than the holes in the top and bottom aluminum plate. That is because I don't want to touch this plate, so I have some margins cut out of this vibrating plate. So we can loosely line the holes. Then another gasket. Then we have to mount this. But first what we need to mount is the speaker. As you can see, the speaker is mounted right here. And then this part actually touches the aluminum plate, the aluminum vibrating plate. So first we're going to mount this with 4 M4 screws. So the speaker has 2 connectors right there, and they are exposed to be able to be plugged into the rest of the electronics later on. The way that everything has been designed is that when I put this right there, this middle part of the speaker barely touches this vibrating plate. But when we're gonna clamp everything down with all the screws around, this is gonna press even more onto the vibrating plate, which is what we want. So basically those 2 first gaskets that we put in have really 2 main objectives. First is to create a barrier against the water, but also it allows this vibrating plate to actually vibrate between the large aluminum pieces, basically. So we have the gasket. Oh, wait. Forgot. Because we have to mount all the electronics, so the battery and the Raspberry Pi, the amplifier, we have to put those plastic parts. These are just simply printed parts, printed on a simple FDM printer. And that's it. And that's it basically for the mechanical part.
So we just have to line the holes, that's great.
Then, so I'm gonna put on the electronics now, but then afterwards I will have to put the final gaskets and then the top cover. And the top cover will be fixed with 20 screws all around. So now, let's put this aside and let's talk about the electronics. So the entire electronics is built around one Raspberry Pi. I've used a Pi 4, but you can use other ones. A battery. I'm using a wireless electric tool from Bosch, 18 volts. And I'm using this adapter to basically connect the battery to the Raspberry Pi, because the battery is 18 volts and I'm gonna actually need 5 volts for the Raspberry Pi, but also 18 volts for the amplifier. This is the amplifier, so that goes from the jack to the speaker basically, but you also need 18 volts. So that is actually perfect for our application. We only need this battery. To connect, to transform the 18 volts into the 5 volt for the Raspberry Pi, I've actually used a custom PCB, but I've actually fried the DC-DC converter. So I've used, as a last resort, I've used off-the-shelf, so it's not custom, the off-the-shelf DC-DC converter from 18 volts. You can adjust it from 18 volts to 5 volts. And then I'm only using this PCB for the connectors. And I'm using these connectors to connect to the battery. The way that it works is that you plug your Raspberry Pi like so. Yes, like so. Perfect. So this is it. So you still have your USB ports. Actually, don't need this one. So you have access to the USB ports, and you also have access, and this is extremely important, to the audio jack. You can see that I forgot to design it into the plastic box. So I had to cut it out with a utility knife. And that's basically it. And what you have to do is just slide it in, and this connects automatically. I don't have an on-off switch on my custom PCB, so it just turns on. And it boots up. It automatically connects to my smartphone, and then I can play the sounds. If we connect everything, so I can disconnect. So I can just turn on the system. So for testing purposes, I'm not gonna put all the screws, but basically what you have to do is to clamp everything down. Because of the weight, the sheer weight, even if I don't close all the way the enclosure, the metal plate is still gonna vibrate because of the weight, it's gonna be just fine. I'm connecting to the Pi over SSH.
Alright. It's only this next singer's 4th time singing in this pub, so cut him some slack. He's singing something new.
And that's basically it. I can shut down the Raspberry Pi. And then I can just disconnect from the battery, and that turns it off completely. I want to thank JustAway, who sponsored this video by making all the parts, all the big mechanical parts for this video.